We're going to talk about the emerging technology of computational storage and how it can be applied to various applications, in particular today, eDiscovery, and kind of how that works. And we'll show a demo of a proof of concept system that I built. So who am I? So my name is Dan Pollock. I'm the CTO of a small technology consultancy in Northern Virginia. Primarily our customers are government and some industry as well. We focus on solving systems level problems primarily related to storage, all of the name of the company, but also related to infrastructure in general. Before this, I was a chief architect and system administrator and a bunch of other things at America Online, AOL, now the Yahoo Media Group for the last 23 years. And while during my tenure there, I basically did a bunch of work around scalable storage systems, storage area networks, and the back ends of large web scale systems for serving the internet customers that AOL kind of built and developed over time. And then later on, media and advertising customers that became AOL's business after the sort of first wave of internet boom occurred and collapsed. So anyway, that's who I am. So we're going to talk about computational storage. It's incredibly interesting, useful, and in the future going to be valuable technology for folks to get additional work done, or even just work done with the existing resources that they have without extending into larger and larger and more powerful systems when you have all this sort of idle capability sitting around in systems that are either secondary or built for some other specific purpose, but have plenty of capability to do additional things that are assistive in whatever your real workload is. So in this case today, we're going to talk about some eDiscovery capabilities that are enabled by optical character recognition of documents, right? So that's a lot of words and it sounds really sort of complicated, but in truth, it's basically we'll build a storage system out of this technology. We'll create a capability for turning images into, or discovering the text in images and turning those into text, and then creating the output that gives people the ability to index that later on. So just a quick overview, right? What is computational storage? I'm the end user, so there are industry folks who can do this a lot better than I can, but basically, you take a traditional storage device, you attach a compute complex to that traditional storage device over a very low latency, very local interconnect, and that minimizes the amount of IO that has to occur between the compute capability and the storage capability of whatever system you're building. And that IO reduction allows for improved latency, and it also allows for seamless back-end processing of data that you would normally have to collect from the storage, process through a CPU, and either send back to the storage or send outbound to some customer for whatever their request was. So the computational capabilities have a lot of varying different options. Some of them are very low-level storage-related applications, things like just compute erasure codes. And that's pretty nifty if you're an industry guy, but not super exciting if you're an industry or end user consumer of systems and devices and capabilities and technology. So my demo is focused on something higher level, which basically says there's an application running on the storage right along with the storage system itself. So not only am I storing data, which is the sort of primary job, but I'm also providing an additional capability that gives me the ability to analyze that data. In this case, like I said, it's optical character recognition. And why would we do that? So optical character recognition allows us to take images in, find any text in those images, and then provide that text output with a link to the image so that you'll be able to associate this image with that text, and you'll know that if there's something interesting in an image, you didn't have to read through every image manually to find all that interesting data. And then once that text is out of the image, but associated with the image, you can then index them together, and that creates a searchable archive, and that enables eDiscovery, and that's sort of useful for things like legal work and document management and all kinds of useful applications. So like I said, I'm taking the computational storage devices from NGD systems, building a storage system out of them using open source software. In this case, it's MinIO, and I'm building an object storage cluster. I'm putting files into the MinIO storage cluster with the S3 API, which is basically an AWS developed object standard. And when that file gets into the storage system, if it's of a specific type, I'm launching a webhook that runs some software that performs optical character recognition on images and then stores a text version of the file that only has the text from the images in it. And we'll show you that demo. But here's how it works sort of at a high level, just so you can see the picture as opposed to me telling you how it works, right? So files go in, the object store accepts them, the computational backend performs optical character recognition on them, stores a text version of the file that only contains the text that was in the image, and rinse and repeat. And the nifty thing here is that the simple act of storing the file creates the output of the text object. You don't have to do anything. You don't have to invoke any additional processes. It's all just running in the background as part of the storage system continuously. So there isn't a separate process, and there isn't any additional capability or hardware that you need to make this happen. Just having the code written and running on the computational storage system creates that capability, which is secondary to the primary role of the storage system, which is obviously storage, but it gives you this sort of nifty additional function that if you are interested in, you get for basically free. And so here's the demo buffer here. Let's do, so I'm going to copy those files into the buffer or into the storage system. That looks right. So that's one of the files in. Let's put a second one in. Oops. Okay, so those two files are in, and the system will have processed them. Just to give you an idea of what they are, here's the barcode. So obviously you can see there's barcode and the QR code and some numbers. So that's what we would expect the system to recognize. And I'll put that there. And now we'll do, I'll take a look at the text version of that. And there's the text output of that file. I believe that's correct. So clearly I've taken an image from this document, which is basically just barcode, which is decent enough, simple, straightforward. And I've created the text representation of that, which now I can then index. And so if I'm looking for this barcode for some reason, I know that I have this somewhere and I know what's in it. I don't have to wonder what that barcode is. And that's kind of a nifty thing. I'm gonna look at the QR code. So that's the text representation of the QR code, and I'll show you the QR code actual as well. So this is a bill, and it has this QR code, which is why it's called that. But you can see that the text from the bill is effectively more or less optically recognized and transformed into text in this file. And obviously formatting is a problem. It's just a POC, but all of the data is there. And with more sort of diligent code on my part or somebody else's, this could be cleaned up and made very well formatted so that you would have effectively the text representation of what you were getting. And that'll allow you to index the text of images, put the image with the text in whatever data store that you're looking at, and then get the information out. And so that's the demo, and that's how it works. And it's pretty nifty. So that's the demo. So why does that matter though? And the answer is because if you're presented with hundreds or thousands or even more pages of documentation that have been scanned in as part of a discovery process or just a document management process, right? Then you're going to want to know what's in all that data. Simply digitizing them, which a lot of agencies in the federal government, like the U.S. Patent and Trade Office, do, is very interesting because that makes all of the historical work that they've ever done accessible. But it's very difficult to search that documentation when they're all images. So if you scan in 100,000 pages, you now have 100,000 pictures. Then you have to know what was on those pages. If you don't want to hand code all of the text or references to those images or those pages, then you have to do something else. And so optical character recognition gives you the text basically for free. And then you can index that text and associate it with the image. So now you can see the entire image, like in the case of US Patent and Trade Office, it would be maybe a diagram with figures, and all those figures would have all of the annotations and text. And knowing that that figure had this text associated with it, and then being able to index that. So when somebody searches, better mousetrap, they're given all the mousetraps in the world, and they're given the diagrams and the text and why they're better. Then that enables an enormous amount of efficiency, both for folks in the public who are looking to see if their thing is different or new in the case of patents, right? Or for legal folks where they're looking for that sort of needle in the haystack where some event has occurred or there's some documentation of something that you're looking for, and if you could only find it. And this way you've got all of the images, so you have the original sources, you've got the text, so you can index it out and make it very searchable. And those two things combined enable both of those use cases and save a lot of people a lot of work. So now instead of reading through hundreds of thousands of documents, potentially, you're simply indexing them, and this system indexes them or optical character recognizes them automatically and then provides you that input for indexing. And then there's no manual labor associated. And that's why this sort of thing is really, really interesting. And all this capability is made possible with computational storage. It gives you the ability to build higher level functionality into your basic storage systems and get not something for nothing, but make use of something that you've already got that's underutilized. So it creates an enormous amount of value from something you already have. So thanks, that's the demo. If you have any questions or if you want to talk about the demo or any of the other things that we looked at here any further, you can reach me at ds-science.com. Check the website. There's all the usual contact information stuff. And you can also ask the NGD Systems guys how to get a hold of me.